So chaff carts were the first thing that were introduced into WA to do this. They came in the mid-1980s, right at the start of when herbicide resistance was starting to take hold around Wongan Hill. And they are quite effective. This data is actually reasonably old now. 85% of ryegrass and wild radish can potentially be collected using these systems. We now have a new system of chaff cart. Previously they were a cross auger and a blower system that was attached to the header that would take the chaff material off the top sieves. Now we've got a conveyor belt system that takes that material up into the trailing cart, and that's led to some dramatic changes. What it does with the conveyor belt system is actually leak quite a bit of straw into the chaff material, and so that the heaps actually burn out in a few hours now. So they'll burn out in 4 to 6 hours typically for wheat. Previously it was up to 2 to 3 days, so that's a much more feasible method of controlling than previously. So there's been quite a rapid uptake of chaff carts in WA over the last 2 to 3 years. The demand has just gone through the roof, and there's only 2 manufacturers commercially in WA, and they cannot keep up with the demand. The rumour last year was that there was a demand for 80 units across WA, and I think they're only able to build about 20 between the two. So the next system that I guess was introduced was developed by the Shields family in Wongan Hills. Again, Wongan Hills, it's the home of ryegrass resistance. Bale direct system where all the chaff and straw delivered onto a conveyor belt into this square baler here. The baler is attached to the harvester and actually being driven via a hydraulic motor from the harvester. Very efficient in terms of weed seed collection. So for ryegrass, we determined that 95% of what went in the front was leaving the paddock in those bales. So all being packed up, shipped off to into the live sheep export trade. Actually, the bales in this situation were being on-sold to a palleting plant, and that was the primary reason for developing the system, was to make money out of the baled straw. Burning it in the rows. This is still the most popular system used in WA, has been for 5 or so years now. It's a simple system. It's just a chute on the back of the harvester, and then that just concentrates all the chaff and straw material into a narrow windrow about 500 to 600 mils wide, and then you come back in the following autumn and you burn those windrows. And now that's the hard part. The easy part is doing this. The hard part is actually getting those windrows to burn right to the soil surface, because that's where all the weed seeds are come autumn. But very, very efficient. If you get it right, get that burning right, you can pretty much get all your ryegrass and your wild radish that comes in the front of the header. These are some of the tips with getting it right in WA. Now, you guys, take notice to some of these things, but maybe all of them will apply here, but it really is one of these things where farmers tend to have to work it out for themselves, I think. I don't think there's any real sort of hard, fast rules of what you should do in each situation. Reducing risk is obviously key, particularly in cereal crops. A good fire break. Non-cereals are dead easy. There's never any, never say never. There's very rarely any problems with canola or lupin crops when you're burning windrows. The fire just doesn't carry through the stubble of those crops. Leave the big cereal windrows until last. Again, that's just a reducing risk thing. So the big cereal windrows will burn quite well anyway, even under cooler and damp conditions. Slow burn is a good burn. You want to get the maximum heat to the soil surface. Crosswind is probably the best. You need wind to get oxygen into the fire. So without oxygen, the windrows will tend to burn across the top. They won't, and they'll smoulder out underneath. So you do need that oxygen flow. The way that this is from the Messinas in Mullawa, the way they tend to do it is they light up every 200 to 400 metres across the paddock. So they'll drive across the windrows, and every time they hit a windrow, they'll light it up, go down 200 metres, come back and light them up. And if they do that in a crosswind, then the windrows just creep along sideways along the length of the windrow. So yeah, they've got the system set up so they can do a fair bit in an hour. So this is probably the perfect scenario. This is a 3-ton wheat crop stubble. This was being burnt in late April. I think they'd had nearly 2 inches of rain on this. There was wild radish coming up through the windrow, but it still burnt really well, and there were no problems of it getting out into that stubble. So it crawled along there nicely. This is the Harrington seed destructor. Now, all these other systems I've talked about are quite destructive on the residues in terms of removal or burning. What we have been looking for some time is a system where we can actually just process the chaff material during harvest, and that's it. We've killed our weed seeds, and we can just start thinking about next year's crop without having to do any follow-up residue treatments. So this is the thing that Ray first came up with. It is a cage mill system set up here. We tested that mill and found out that it did actually work on killing ryegrass seed when we introduced chaff laced with this ryegrass seed. When we gave Ray those results, he said, righto, I'm going to build something, and he certainly did build something. It found all the bits and pieces lying around the yard, bit of a header motor, fuel tank, some corrugated iron, bit of tin, rubber, string, spare wheels, a bit of tubing, and put this machine together. Yes, it's just missing a bike wheel and a bit of duct tape, I think. So look, Ray was explaining it to me. He was pretty proud of it, and he could obviously see that I was a bit doubtful about the whole thing. So he decided to demonstrate it. And Ray's method of demonstration is quite something. So he's just scooped up half a bucket of gravel from the yard and decided to tip it through the mill just to show how well it would work. And of course, we were a bit horrified because we'd left the car sitting at the back there. But thankfully it worked, so the car was safe. Okay, so yeah, we subsequently tested the system after we tested Ray's system, and it worked. I mean, we should never have doubted him. I'm going to say that we subsequently got the engineers involved from the University of South Australia, and they refined it all and modified it a little bit, and it still just does exactly the same thing as what the rough and ready Heath Robinson version did. And under commercial conditions, we were getting these levels of weed seed destruction for those 4 species, so it works. It works on the weed seeds that are in the chaff material. So I went into commercial production last year. There were 2 units sold. The De Bruin Engineering Company in Mount Gambier in South Australia have the commercial contract, and they are now building and supplying them. GRDC took on the project after Ray built that system, so they have ownership of the technology. They took out the patent, and they contracted De Bruin, or they signed off on a license for De Bruin to build them commercially. So that's the situation with the HSD at the moment, and what it is, it's the introduction of a highly effective chaff processing system. So no need, as I said, for post-harvest operations, and importantly for WA and probably for you guys here as well, it allows us to retain all our harvest residues. Absolutely critical for soil moisture retention, and highly important for nutrient retention as well. I'll flick through a bunch of slides but just to show this point. There was no, when we did a whole heap of trials across WA and Southeastern Australia, we found no difference in the efficacy of any of these systems. They all do the same job when they're used properly, because they are all targeting weed seeds in chaff. Okay, so that's a given. This is our message now. This is some excellent work that was started by Peter Newman back in 2001. It's a focus paddock study, and what he did was he worked with 26 growers, 25 growers in the northern region of WA to identify problem paddocks. So paddocks that the growers are having difficulties in getting the ryegrass populations under control. So these growers then implemented strategies to control these large populations to get them down to as low as possible numbers of ryegrass. And as I mentioned earlier, we're now looking at a zero tolerance thing where we're wanting less than one plant per metre squared at least. Now the way that these growers way it panned out was we finished up with two groups of growers. Ones that relied on herbicides alone for controlling ryegrass, and the others that used herbicides plus harvest weed seed control. And typically they were using a chaff cart or narrow windrow burn. Okay, so we're looking at the in-crop ryegrass plant densities in about August, so after all the early pre-em and post-em herbicides have gone out. So these are the survivors in crop. For the guys who relied on herbicides alone, as you would expect, they did a really good job, so they've still got some herbicides in the system that work. They get the numbers down to quite low levels, so by about 2008, after really hammering the populations for 7 or 8 years, they're down to between 3 and 5 plants per metre squared consistently on average. So not too bad. For the guys who are using herbicides plus a windrow burn or a chaff cart, again, they get their numbers down, but they get their numbers down to less than 1 plant per metre squared by 2008, and ever afterwards it's just bobbling along that zero line. So always less than 1 plant per metre squared, but not quite zero in all years, but the sorts of numbers that we're actually looking for. So the moral to the story is herbicides are great, herbicides are fantastic, and we cannot crop without them. So if you want to preserve your herbicides, then you need to do this. You need to do that plus harvest weed seed control. Plus harvest weed seed control will never replace herbicides. They are just not good enough to do that. But when you introduce them into your systems, you really do take the pressure off your herbicides. Now, the other interesting thing about this, on average, for these guys using windrow burning or chaff carts, they're only using them about 2 out of every 3 years. So they weren't necessarily using them every year, but on average across that whole period, 2/3 of the time they were using a harvest weed seed control system. I'll just finish off with this one. So this is what's next with harvest weed seed control. There's a mill in the back of the harvester. All right, so that's where we're headed. Hopefully within 5 years these will be commercially available. So this is a mill. It's actually 2 little mills that have been fitted into the back of the header, processing the chaff. The mill is being driven by the header. So yeah, so look, that's the future. We've got to make sure now that this works on our weed species, and it works under under commercial harvest conditions throughout the harvest period. So that's what we'll be doing.